Okay, good morning. Thank you all for taking your time out this morning to come and listen to a toolbox talk on self-retractable lifelines. Do you use them safely? Is kind of what we're going to look at today. So, getting straight into it, what we're going to kind of look at is we're going to kind of look at some of the differences with retractable lines, why we use them, kind of what they were introduced into the market for, and kind of go from there. Within the market, they obviously have lots of different names. People refer to them in a wide variety of different names as such. So on the screen now, I've included the three most common. So most people will refer to them either as a self-retractable lifeline, a fall arrest block, or a retractable full limiter. So obviously probably the key one being the last one, the word in there, full limiter, is kind of what we're going to discuss and how and why they work. Okay. So when we are working at height, we tend to use two common things. We have restraint, which you'll see my user there. He's walked out as far as he can with his restraint lanyard. The restraint lanyard stops him experiencing a fall. And the other term we have in height safety is we have fall arrest. So the other user, he's using a lanyard and he's working in a position where he can't prevent a fall from happening. So that, in case he has to use a fall arrest device as such. Okay. So the different types of fall arrest equipment that you'll see. So on the screen there, we have a rope and grab system, the self-retractable lifeline, and probably most common, the fall arrest lanyard. Okay, so I'm just going to bring up a close to those. So we could just drop the slides for a second. Okay, so this is my example of a fall arrest lanyard just here. It's a 2-meter rope. It has a shock absorbing pack on it, and that shock absorbing pack is what's designed to be safe for the user. Okay. Rope and grab system is what we have down here. So the user will climb up and down the rope. They slip or fall, and the rope grab's going to lock off, and the shock absorbing patch is going to catch them as well. Okay. And then the reason that we're here today, the retractable fall limiter moves freely. Event of a fall or a slip will lock off and work like a seatbelt. Okay. So why are there different types of these? Well, on a shock absorbing lanyard, we've got the 2 meters of rope. Obviously, a user cannot withstand the strength in a fall of this. We're talking potentially 18 tons going through the body. Okay. That's why you need the additional shock absorbent element to it. Okay. Within this pack, though, there is 1.75 meters of extra webbing. That's all been sewn together and compressed into this pack. And then on impact, it's the deployment of that teared webbing, which makes it safe on the user. Obviously, then to use that safely, 2 meters of rope, 1.75 meters in here means height of the user, meter of clearance, 6.75 meters to use it safely. Okay, so that's why the term retractable fall limiters come into play. If we can just pop the slides back up. Okay, so your open grab system and your self-retractable lifeline being introduced to where you have a full clearance of a lot less than 6.75 meters, you can obviously use these safely, and these will catch you in that sort of environment. Okay. So we've got the full distances there from a fall arrest lanyard compared to a self-retractable lifeline when it's connected directly above the head of the user and the user was to step off the side. So in the image with the fall arrest lanyard, as I said, the ABC, that's your shock absorbing pack and your lanyard. B is obviously the height of the user, and then C is your clearance. And that's what equates to the 6.75 meters in total that you will need. Obviously with a self-retractable lifeline, where they work similar to like a seatbelt will. The user moves freely. They slip or fall, and it's going to lock off pretty much instantly. Okay. So that full clearance goes from 6.75 meters when it's connected just above your head height to about 2.5. So obviously greatly reduces how far you're going to fall. Okay. So what we're about to play is we've got a video on self-retractable lifelines. What it's going to kind of show you is how they work when the device is connected above the head. Okay, above the head is key if we think about that when we're watching the video. And what it's going to show is how far a user will fall when he's directly underneath a fall arrest block, how far he will fall if he's potentially kneeled down, how far he's then going to fall if he walks out a certain distance from his anchor point. So with vertical fall arrest blocks, you have a maximum degree of 40. Okay. Within this video, we're going to kind of show you what happens when you kind of go beyond that 40-degree limit. All right. Okay. So obviously very kind of good brief video there kind of showing you how they work. So obviously you can all see from the example there, it's myself walking on a train. Obviously I take the step off initially, I fall in about a meter. Anchor point is right above my head. I've just taken the step off, block's locked off straight away. Caught me, easy peasy. The second scenario is when I crouch down. So what's happened there is I've actually added on, where I've crouched, I've added on a meter of length to the block, which in turn means when I've then fallen off the train, I've had to account for that extra meter of where I've been crouching down doing the work that I've been needing to do. Okay, so in that sense, it would probably be about 2.5 to 3 meters that I've fallen. Obviously, you have to think about height of a train. We're not talking crazy high, hence why you would need to use a fall arrest block. And if we think about scenarios like that, that's where obviously you're going to need to use something that's a fall limiter as opposed to a fall arrest lanyard. Okay. Obviously, the other scenarios where I've walked out past 40 degrees, obviously I haven't accounted for that. So there's some racking set up. So where I've then stepped off the train, we have what we call the pendulum effect. So where the block will be centered in the middle. Obviously, when I step off, as per gravity, that is going to have to turn me all the way until I reach back to the middle. Okay. So the pendulum effect is then what's brought me back past center, taken me back past all the way to the left-hand side, which is then in turn from the video obviously crashed into that piece of racking that you saw. Obviously in that scenario as well, you're going to add on a little bit of extra fall distance as well. So once you've kind of accounted for that, you're probably then starting to get onto about 4 meters of fall, because obviously when the block locks and I've walked, say, 4 meters out, it's going to lock off. It's going to swing me back from that distance. Okay. So in the scenario, yes, I had enough fall clearance, but something to think about. Okay. So obviously certain fall factors will limit what SRLs you can use. Very relevant to kind of a recent standard that was introduced relevant to sharp edge testing of fall arrest blocks. So previously, manufacturers would have stated, or some would have stated, that the blocks could be potentially used vertically or horizontally. Just going to show you that if we could just drop the slide a second. Okay, so certain blocks, people will say, yeah, vertical use catches me, fine. Horizontal use catches me, fine. Okay, from that, people would then say, okay, great. So that will be the same for the bigger blocks as well. So this is a 10-meter block here. I've got it connected at the side, got it retracted out, and it locks off. From the new standard that was introduced, basically, there was now a physical test for when it was used horizontally and potentially somebody fell over the edge. And what kind of happened was you had to bring in the thought of a shock absorbing element extra to it. Because what happened is when this was used horizontally, if the person was on the same level, it would catch them fine. We've established that. As soon as you incorporate an edge for that, basically the wire would slip and it wouldn't catch straight away. So what that then did is I've then put more force onto the device itself, where in circumstances the wire might break, but more importantly, the force in the fall was going to be too high, so it was no longer safe on the user. Okay, if we could just bring that slides back up. So most commonly, vertical fall arrest blocks now will only be able to be used in a full factor of 0, which means it has to be connected above head height. Okay. From the standard that was introduced, from the horizontal sharp edge standard, you now have certain blocks that can be used in a full factor 1, which is connected at waist level. So what happens is you take a fall, you're adding in a meter of extra fall because obviously you've got that meter that you have to fall before it even catches you. And also blocks that can do the full factor 2, which is connected at feet level, which means you're adding in 2 meters of fall. So the user will fall 2 meters plus 2 meters before the device even catches you. Okay, so think about you're falling 4 meters before the device even connects, and then obviously there's more slippage to that as well. Okay, obviously this is relatively new, so there'll be a lot of people out there still using blocks that they at the time were told these could be used horizontally, these could be used at feet level. Actually, they no longer can. All right. So I've put 2 examples on the screen, just showing you the differences really between 2 blocks that look very similar, but that one that can be connected at feet level, connected at waist level, and can be used horizontally. Okay. Obviously, I've put the additional standard on the screen just so you can see it and just something to look out for the blocks that you're currently using. As I say, if you're ever told the block that you're using could be used horizontally, you then go to check the block itself, and actually it doesn't have the VG11 standard. Obviously, the 11-060 is the important bit. Chances are that block will no longer be okay to be used horizontally. Or if you contact the manufacturer of where you got that block from, they will probably have a new block that's been added to the range specifically to be used horizontally or over a sharp edge. Okay, that's exactly what we've done there. So just side-by-side difference. I've got them just here on the thing. If we just drop the slide again, sorry. As I said, what we needed to do was increase a shock absorbent element to the horizontal block. And you can see there, we've got the additional shock pack, which allows it to do that. Compared to the standard vertical fall arrest, obviously there is no shock pack there at all. Okay, so obviously vertical only can be used vertical, can be used horizontally. Okay, obviously all the standards will be on the blocks themselves. Obviously, as we are adding shock absorbing pack to that block, we obviously would have to allow a little bit more full clearance for that. So when we're using this vertically, we recommend 3.5 meters if it's connected just above head height. Okay. As for if it's above head height here, obviously we have 2.5. But obviously horizontal, non-horizontal. Thank you very much. Okay. So manufacturers, they should really all kind of direct you on what can and can't be used. So the block that I've taken on the screen there, this is just an example of the mini fall arrest block. So the one just here in my hand. It gives you all the indication of what that block can do. So obviously for this particular one, you can see we've got EM360, which is your standard fall arrest block standard. And then we have the CMB, which is obviously used for horizontal and sharp edge. And then the icons on the block kind of indicate that as well. So you can see we've got the horizontal with a tick, we've got over a sharp edge with the green tick, both limited to 100 kilos, which is obviously something to bear in mind. Obviously, to use vertically, it can weigh up to 140 kilos, the user. All right, so obviously where we're adding a lot more force into the fall, obviously that then limits how heavy the user can be when they're using the equipment. Okay. Just gives you some guidance as well there with obviously temperature use, where to use them, weather, etc. Okay. So obviously I said when we're using above head height, we look at 2.5 meters for vertical fall arrest blocks and 3.5 meters for horizontal use blocks. We've then done some calculations and equations, and all this information here, as well as the video that you just saw, is on our JSP Go system. So what you can do is you can, if you're a bit unsure how far the user might fall when they're working, we've just got some tables. You can pop in the numbers and it will give you a rough idea of how far that user might fall. So say we've got the fall arrest block connected 3 meters up, the user needs to walk out 4 meters to where they need to work. It will then put in the sum and it will bring out how far that user might fall if they were then to go over the edge, say. So you know from a risk assessment point of view, if that user ever was to come off, they've got enough clearance beneath them for when they swing, they're not going to hit anything. All right. Lovely little tools just to kind of play with. And I say that's our JSP Go system. We'll drop the link into the chat at the end there. So if ever you want to head over and have a look, you can do. Okay. So finish with some bad examples. Obviously, always tend to have a little laugh at these, but obviously it's also very concerning at the same time. So what I've got, first of all, is there's a picture of a block that's been used. Obviously, you'll see the condition of it. This has still been used relative to the last few weeks in this condition. And then the final two examples are people that are using fall arrest blocks. And we'll kind of talk through them to why they are bad examples as such. So this first one, this block was manufactured in 2015. Obviously, I don't really know too much background to it, but what I was asked is, can this block still be serviced and put back into use? So the lifespan of these is 10 years from date manufacture anyway. I was kind of dubious on when this was last serviced. I mean, as you can see, the corrosion on it is incredible. I would imagine this is used quite close to a marine environment. So there's a lot of salt water, which has obviously corroded the wire and the connectors over time. I would assume that this hasn't been serviced for probably 10 years. The date of the block is the 2015, so the user obviously has had a lot of life out of it. It just hasn't really been maintained or taken care of, and obviously I've been advised to purchase a new one. It's quite clear on the connector itself. You can see the corrosion damage, and as I say, I'd be pretty confident that would be down to like salt water and a marine environment. And obviously, you can also see the rust on the wire itself. As I say, if this had been sent in for a regular service, this would never have happened. Obviously, these blocks should be sent in for a yearly service. Our specific ones is you can use them for 3 years from once you've bought them. You can do a general inspection on those first 3 years, and then it would be the 4th year that they would be sent back to us to be serviced and maintained. Okay. Obviously, this particular block, if we were going to try and repair it, try and resurface it for them, it would literally have 6 months left in use. And more importantly, it's probably going to cost them more for the repairs than it would be to just buy a new block in the first place. Okay. Obviously, look after your blocks. Very important. Okay, so we've got the first user here, where he's using a specific brand of product that this manufacturer would always claim this block would be okay to be used horizontally. As I say, they've now since gone away and obviously designed a block since the standards come out where they do have a block that can be used horizontally, but this particular user is still using the old version and using it in a horizontal scenario. So as you can see, what he's done there is he's added to an extension strap. So he's essentially added an extra length of rope to that. First of all, the block itself will not have been tested with that rope. So we don't know in the event of a fall how much force is going to go through that. Is that going to withhold the user? Is it going to put too much force through the user? Is it going to put too much force through the harness? Okay, so that's always something to look out for. Obviously, he's going to be working at the edge of the platform that he's on. He's obviously set his hangman system up and connected the block to it, but basically the hangman system isn't high enough. So that's a standard block, and he hasn't even got close to the edge yet. And you can see the block itself is really already over the 40-degree angle that he can use it at. So by the time he gets to the edge, he's going to be close to horizontal 90 degrees. So it means in a fall, is that block going to be able to hold him? Because the wire, there's going to be a lot of force that's going through the wire over the side. And more importantly, how much force is that going to put through the user in the event of that fall? Okay. So I don't like using visuals, but it's always good just to give examples because unfortunately, this is just a general form worker. He's basically building edges to the roofs. He's putting the platform in. It's all very common work. And as I say, he's just not using the correct equipment for what he needs to be doing. Okay. So the second one, obviously, working on flatbed lorries is always very, very difficult. This particular user has kind of gone to the extreme, and I don't know how well you'll see it on the screen, but he's obviously set up a hangman system with 2 4S blocks on it. So that flatbed lorry is going to probably be the best part of, I don't know, 7, 8 meters long potentially. So his height from what he would potentially fall at is going to probably be a maximum 2.5 to 3. So he's thought, okay, I can't use a 4S lanyard. I'm at risk of falling. And he's gone, great, I'll set up a hangman system and I'll use 4S block because if it's connected above my head, I'm only going to fall 2.5. I won't touch the floor. Obviously, since they've set that up, the user has then decided he's going to put on his harness, he's got up there, and he's then going to connect to the furthest block in the picture. So what you can see, if you look closely, is the block closest to him actually doesn't have any connection to it at all. It's not being pulled. The block furthest away is actually being pulled directly towards him because that's the block that he's decided to connect onto. So we thought about the length of the flatbed is going to probably be about 7 meters, and he's got about 3 meters, 4 meters to fall. If he steps off the side there, the pendulum is going to swing him straight into the ground, and he's going to basically fall. He's not going to be close to having enough fall clearance for what he needs. Hopefully that will make sense because it's a lot of words I appreciate. But yeah, if you think 7 meter long truck bed, he's connected to the one furthest away, so he's already got 7 meters of line. He then steps off the side, slips, falls. You just don't know what's going to happen. Because of the pendulum effect, he's going to try and bring him back to the center point of the block. Obviously, it's locked off at that length. So that length has been locked off at 7 meters. So to be able to do that, he's then would need to fall or have full clearance of 7 meters to obviously avoid contact with the ground. Okay. As I said, so I apologise that went on a little bit longer than I expected. I thought 20 minutes, and we do have allowed a little bit of time for some questions. So if you do have any questions, feel free to pop them into the chat, and we'll have a look at them. Again, thank you for your time. Okay, yeah. So just on the weight there, question just popped in. So obviously I mentioned when used vertically, the vertical 4S blocks can be rated to 140 kg. The same with all the other blocks as well. So as soon as you move into a horizontal situation, that the horizontal blocks then limit the user to 100 kilos in the event of a fall. Okay. All that's just due to is the amount of weight that's pulling and it's pulling across an edge. Currently, we just can't get to 140 kilos. Okay. Okay, yeah. So question in there about do we offer training? We have a training team across nationwide. We can go across Europe if need be to deliver working at height training specifically on what you're doing on site. So whether that be using 4S, restraint, using both, we can come and kind of train the users to do that safely. Again, it's a legal requirement to have some sort of training if you're working at height. So whether you've just working in a mute, for example, or going day to day working on a rooftop, you have to be trained to do that. Okay, so question on, again, kind of going back to the lifespan of the blocks. So as I mentioned, they can have a 10-year lifespan from date of manufacture. Obviously, with lanyards and harnesses, once they kind of experience a fall, that's them in life done. The fall rest blocks have a fall indicator, which you can kind of see there. So that's showing as green. What happens is in the event of a fall, that'll pop through and be showing as red. What that means is it can be sent off a service. Parts can be looked at, can be changed. The wire can be changed if needed, and then it can be put back into use. Okay, but as soon as that pops through, it's had a force enough for that to pull through to showing as red. That then needs to be sent off for a service. Okay. Any more, or is that, are we good? Okay. Yeah, I think that's it for now. But obviously, if there's anything else that kind of pops in into your mind, just give us an email, send us the question that you're thinking, and we'll get back to you. And as I say, thank you all again for your time this morning. Yeah, thanks a lot. See you next time.